referencing any products that are from that company, but just in the interest of full disclosure, thought I would point that out. So first of all, let's talk a little bit about what a functional gap actually is. So functional gaps are quite simply just differences between what a system does now, your current state, and what you really need it to do to fully support your workflows. So here are some examples of functional gaps that I've encountered in my career with relationship to the LIS. These include things like adding a molecular laboratory information system or LIMS functions. This is actually something we're working on right now. We're trying to find to add to our system a dedicated molecular LIS. Other things such as synoptic reporting modules, asset barcoding and tracking, which has been, really most people have this now, but traditionally this has been one of the functional areas that people did not have in their laboratory information system. Pieces for coder billing review. So in the United States, we have a lot of billing that happens. It's one of the things we have to deal with. And over the years, especially in our previous LIS, this was an entirely separate module that was built in-house because the system we were using lacked this functionality. And that's how that was solved. Things like event-driven notification. A lot of LISs can't do very much event-driven notification, and you're left with perhaps adding some interfaced piece of software to it to actually get notified when events occur. Issue tracking and quality improvement. This is another area where many LISs do not do well. And I know that I recently reviewed a paper in this area where someone had some really interesting homegrown solutions. And so this is another example of a very common functional gap. Search tools, this is something probably the number one issue that's brought to me about functional gaps in laboratory information systems is the inability for people to actually get information out of them or to get information out of systems that were previously operational and which now have been replaced. So these are just some examples. There are many, many other types of functional gaps that you might see. So how might you identify these functional gaps? Well, the traditional answer to this is to do a gap analysis. And I'm not going to get too in depth on this, but this is really a formal method for identifying and characterizing functional gaps in a system. However, the more common way in which we identify functional gaps is just from reports from users who identify these areas just through using the system and noting that it does not match well to the existing or desired workflow. So again, gap analysis can be a formal process. I'm not going to go into this too deeply, but there are a lot of different ways of doing this, a lot of different tools available. SWOT analysis, the McKinsey framework, now the Tushman model. But like I said, this is useful, I think, if you are trying to actively identify gaps, but in practice, almost all these gaps that are important are going to be obvious to the people using the system. And so these are going to be for more informal gap analysis. The general steps in a gap analysis, even if it's informal, you really need to first describe the current state of your system. If you don't understand how your system works and what it's capable of, it's very difficult to know how you're going to get to your desired future state, which is step number 2, is to actually describe that future state. And then, of course, if you compare your current state to your future state, you will then be able to identify the gaps. And the last step is to formulate a plan that will eliminate these gaps. I think it's really important when we're talking about functional gaps to recognize that all things that are identified, especially informally, as functional gaps may not always be true gaps. I think if any of you have roles in leadership roles in your informatics team, you know that your users have many perceived functional gaps or perceived deficiencies in your information systems. And it's important to really ask yourself a question: is this a real gap? And if it is a real gap, does it actually merit being addressed? I think we all know of those people who have a long laundry list of problems that they perceive in our information systems. And many times it's just one person's desire and not necessarily something that is a true functional gap. And finally, with anything, any problem, we need to prioritize how important something is. It may be a true functional gap, but if it has a very minimal impact, it may not be something that's worth addressing. So if you have identified functional gaps in your LIS or your other information system, there are three sort of broad approaches to actually eliminating the functional gap. The first one would be to buy a solution. The second would be to build a solution. And the third would be to borrow a solution. And I think we have perhaps a good idea of what buying and building looks like. Perhaps you may not have thought about what borrowing a solution looks like, but we'll be discussing all three of these. First of all, buy. I think this should be pretty familiar with people. If you've ever had to pay for software, I think you know what I'm talking about. Most functional gaps in an LIS can usually be solved by purchasing a commercially available solution. And this is sort of one of the major take-home points of this talk, and that is that for most organizations in most situations, buying a solution should be the default option. And you should deviate from this option only under very specific circumstances, and you should really make sure you know what you're getting into before you do something other than buy a solution. Now, you might get this purchase solution from a first party, in other words, the actual vendor of the LIS that you have, or it might be a third party add-on module from a company that specializes in building modules to integrate into other vendors' LISs. So if we're looking at a solution from an LIS vendor or the first party, these might include off-the-shelf pre-built modules that you can simply get a quote for. It might include having them actually build you custom modules. These are the kind of things where if you call and say, I need this solution, they're going to have you talk to their software development department rather than their sales department. That's usually the big divide that I like to think of. I don't like it when I call my LIS company and they route me to software development rather than sales. I would much rather talk to the salespeople because I know it's at least I'm going to pay money and not have to go through a huge software development problem. The last possibility would be custom coding, like them coming in and not necessarily building an entire module for you, but perhaps doing some modifications on the existing modules to make them meet your needs. Basically, the solutions from the third party, basically the exact same set of solutions. It's just that here you're dealing with a company that is not the primary vendor of your LIS. So first party or third party, sometimes you have options to use either a first party solution or a third party solution. And the question then becomes, how do you choose to use which one to use? Well, for many organizations that are highly regulated or larger organizations that have a lot of very proscribed billing process or acquisition processes, you may need to actually put in a request for proposal. I'm not going to get into this. This is a whole nother talk, but hopefully for most smaller gaps, you're not going to have to put in a request for proposal, but many times, in certain organizations, you have to, and you're really left at the whatever your particular policies are as to whether you would acquire from the first or third party. In many instances, like I said, it's really going to be a much more informal process. Here are some of the advantages to go with when you're looking to buy from a first party or your LIS vendor. We would all hope that our LIS vendor is going to be the leading expert in adding functionality to their own system. Sometimes I know if you are ever frustrated with your vendor, you may doubt this considerably, but we certainly would hope that. Because it's their own product, there may be less expense because there's less of a sort of a complex integration. Typically, it's easier or a better integration than a third-party solution, again, because the product should have been built to integrate with their LIS. And typically, LIS companies, some of them, I should say, are very large companies, and you can expect perhaps better longevity. If your first party is a large LIS vendor, they're not going to disappear from you 2 years after implementing this solution, which sometimes happens. The last thing I would add is that it's frequently better to just be dealing with one vendor, whether that is from a contracting point of view or from the point of view of trying to troubleshoot issues. One of the things that plagues us a lot is that when we have multiple vendors who all intersect in a single functional point in the LIS, if we have any problems there, everyone points the finger at everyone else, and it is very difficult for us to actually convince them that it's their problem, and we end up really delaying the solution as well as having to do a lot of the work ourselves when we are paying for support, and it's very frustrating. What are the advantages to third-party solutions? Well, these may not be obvious at first, but many third-party modules are in fact best-of-breed products for that specific functionality. And the other thing is that unlike LIS vendors that have a giant product, if a company just makes one module that does one thing, say for example tracking of barcoded assets, for example, or for synoptic reports, this may be a very motivated vendor because this may be the only product, or this may be their major revenue source, and so they're going to apply a lot of innovation, and they're going to continuously innovate on this product because they live or die by the quality of that product. They're also more likely to update the product in a timely fashion, again, because it's their primary source of revenue. And they're likely a smaller, more agile company, although that can be a problem if they are, if they go out of business quickly, which is sometimes what small and agile companies do. So, like I said, the buying should be the default approach for most organizations, but there might be some very good reasons not to buy, even if a solution is available. Of course, probably the number one reason would be because your LIS vendor is unwilling or unable to provide an off-the-shelf module or a custom solution. And if you think that they will just develop a custom solution for whatever you want, there are literally times when you can bring them a giant bucket of money, and no amount of money in the world would get them to actually build the solution, because it just doesn't align with what they're interested in doing. Similarly, if no third-party vendor will integrate with your LIS, for example, if you have an LIS that is extremely rare or has a very small market share, you may find that they simply aren't interested in doing it. The other problem is if your LIS vendor doesn't exist anymore, of course, like I say here, you have much bigger problems than just filling your functional gaps if your LIS vendor is out of business. So I want to move on now to building solutions. So specifically what I'm talking about here is developing software in-house that fills a functional gap. So if you are instead hiring a third-party company to develop a de novo solution, this is really more like buying. You're essentially contracting with them to build a solution for you. What we're really talking about here is building something within your organization. And I think a key point of this people seem to forget is that your organization is actually assuming all the responsibility for the software development lifecycle. And I think we sometimes forget that the software development lifecycle is more complex than just the programming involved to actually implement the solution. It involves all of these steps, and again, this is not a talk necessarily on the software development lifecycle, but there's a lot more to it than just the programming piece. It involves, planning, analyzing. This might include your functional gap analysis here and analysis, designing how you're going to solve this, finally implementation. And then once you've implemented something, testing, integration, and making sure that it actually does what it's supposed to do. And then over the lifetime of the software, you need to be able to maintain it. And of course, a healthy software development lifecycle is going to be a continuous cycle in which you're constantly going through this and reevaluating where you're at. I think a common mistake I alluded to earlier, a common mistake is thinking that software development is the same as programming. Programming computers is great. It's wonderful to have people on staff who are able to do that, but it really fails to account for the other elements in software development. If you think about programming in relationship to the software development lifecycle, it's really a very small subset of the implementation. It's not even the entirety of the implementation, because this involves a lot of other things such as training and things like that. So programming is just a tiny, tiny piece of the total software development lifecycle. And when I've given this talk in the past, I've given this talk, to pathology informatics meetings where we have a large number of anxious young fellows and residents and young faculty who are all developing their own custom solutions to problems to fill these functional gaps. And I can tell that the room goes cold at this, because everyone who's developing, they're doing this programming and solving these problems, I think maybe this is not what they want to hear. But the reality is, again, that there's just quite a big difference between having great ideas and actually sort of being able to build maintainable code bases and to really participate in the entire software development process. So, I mean, this is a great quote from Craig Silverstein, who is the director of technology at Google. So to be a director of technology at Google, you would have to be very astute and really know what you're doing. And this is what he said about Larry Page and Sergey Brin, who of course founded Google, I didn't trust them as coders. I had to deal with their legacy code from the Stanford days, and it had a lot of problems. They're research coders, more interested in writing code that works than code that's maintainable. So, you know, this is you can think, don't feel insulted if someone says, you know, you really can program well, but I don't want you writing a mission critical piece of my LIS. You know, here's what someone had to say about these two very famous and brilliant guys. I'd also like to say this is another instance of just because you can do something doesn't mean you should. Again, I can think of lots of solutions of things, and I constantly have to stop myself from actually solving the problem because that would sort of create two problems. So here are a few bad reasons. So these are not good reasons to decide to develop software in-house to solve your problems. The first, I'll be talking about a few of these. So NIH syndrome, not National Institutes of Health in the United States, but not invented here syndrome. The hero complex to save money. This notion, which is a planning fallacy of it will only take me an hour or an afternoon or a weekend or week to code a solution. I can solve that quickly. Bob in IT knows a little Python. I've heard people propose that in the past. It's not a great reason to be solving something in-house, or the resident or fellow needs a project, which I've also heard. What is not invented here syndrome? Hopefully you've all heard of this before. NIH syndrome is a tendency to reinvent the wheel. That is to re-implement something that is already available based on the belief that in-house development has inherent advantages, such as it's going to be better suited to the needs of the organization. It might have better performance. It's going to give the organization more control over features or design, or perhaps you think it's going to give you a lower overall cost to implement. This is another issue, the hero complex. I think a lot of people in informatics see themselves in this role. Sometimes it's called the savior complex, but it's really this inherent desire we all have to help people. We want to solve people's problems. That's why we're here, right? And you know, if you're in academics, I think of this as a junior faculty trap, where you spend a bunch of time solving all these little problems and you never do the sorts of things you really need to be doing to be a proper scholarly activities for an academic. Saving money may seem a little bit counterintuitive, but if the only reason that you're developing your solution in-house is because you think it's going to save you money, you may want to rethink that. In fact, it may be a false economy. You need to really consider the total cost of ownership of the solution, including any possible risks to the organization for poorly developed solutions that could be error prone or could fail to work in the future, perhaps when certain staff have left who understand the system better. The other thing I would say is that certain organizations, if you solve a lot of their problems with developing solutions in-house, they actually can become addicted to these cheap solutions. And when you go to ask them to actually spend money on information systems, they say, well, you've solved all of our other problems by programming your way around it. Can't you just solve this one? We don't want to give you any money. And I think you create your own problems potentially when you do this too much. The planning fallacy, I think I've fallen prey to this, and I'm sure most of us have, in that we think it's only going to take us, you know, whatever X amount of time to create a solution. And you know, the reality is that we underestimate time, cost, and risk, even when there's past evidence of exactly what is required. So we make the same mistake over and over again of failing to understand the size of a problem in front of us. Here are some good reasons for developing software in-house. Again, I think I sort of touched on this earlier, but if there's really no vendor or third-party solution to your functional gap, that's when you should really start thinking about developing it in-house. Even then, developing in-house may not be the right solution. For example, the third item here, your organization really has to have a culture of software development. That doesn't mean that you have one guy who can program. It means that you have a history of successful software development, perhaps in smaller projects, and that you feel comfortable that you can manage the entire software development lifecycle. You have to have proper staffing for software development, and I will get to that in a second. And if your LIS has a well-documented extensible design, which I'll also talk about in a moment. So what are the requirements for for software development? This is just a rough list. It's wonderful to have a project manager. I would say that that's probably optional, but having at least two software developers in-house is critical. in case someone gets run over by a bus, for example, or just retires or takes another job. That happened here to us at the University of Colorado. Not the running over by the bus, they just took another job and we were out of the person who was maintaining the software. Having live test and development environments, like a properly set up environment so that you can do proper testing and not just a live environment. I've encountered this problem and it's a real issue when you only have a live environment. Having orderly and secure source control so you don't lose your source. I've encountered this in mission critical home built stuff that we've since replaced. It wasn't my decision to build that. You need to have standard operating procedures for the full software development lifecycle. You have to have some idea of how to do this, and you need to have support for your in-house software at an appropriate level. If this is mission critical software that needs to be supported 24 hours a day, 7 days a week, you need to be prepared to actually provide it, because there will be no vendor to call. That will be you or your team. And finally, documentation. Extensible LIS software, this is the dream for anyone who's building. It's actually LIS software that has better options for third-party extensibility. When I presented this the first time, someone got up in the audience and said, tell me about this Extensible LIS. Which ones do you know of? And of course, I named one. I'm not going to name any now, but the reality is unfortunately, there's not enough Extensible LIS software out there. And this extensibility is through APIs, hooks, or defined namespaces, and perhaps other mechanisms. So finally, the final option here would be to borrow. And this may be a little bit unusual, but I think it's worth thinking about before you reach for the other two. Borrowing can mean, this is, so I think, the really innovative piece, using software implemented elsewhere in the organization. So in other words, if you are in a larger health system or in an academic setting or in a hospital setting, are there other departments or function or organizational units that maybe have software that you can use either on their license, or perhaps you have an organizational a site license, or perhaps you can acquire a license of your own and just use their expertise. The other form of borrowing I'm going to discuss is just implementing third-party software that's been built elsewhere. So perhaps you didn't build it, perhaps someone else built it, but maybe you can acquire that and sort of integrate that into your system. So software implemented elsewhere in your organization, this may not be something that's familiar to people in laboratories. We're very used to being independent, but I've seen all of these leveraged by laboratories to solve some of their functional gaps. So the type of software that might be available elsewhere includes things like middleware. The interface engine can do amazing things, and sometimes you can make it solve problems that you have. You perhaps could put your imaging in radiologies or your enterprises packs, or a vendor-neutral archive. That's becoming more and more possible in pathology with the adoption of DICOM. I've seen dictation and speech recognition systems being leveraged in the lab when they were available elsewhere in the organization. You can certainly, let's say you have an independent LIS module, but your EHR has some modules you might be able to use for certain tasks. We've actually done this here where we have an independent LIS, but the health system has a module that we've used for certain types of testing, for signing out certain types of testing. Document management, perhaps there's a document management system that could be used for a variety of purposes. And finally, perhaps if there's a ticketing or help desk system, maybe that could be leveraged for quality management. Maybe you need to get a little creative, but there are lots. This is one of the, I think, one of the least utilized resources that people have when they're looking to solve their problems, is just to look to see what other of your colleagues have available. Some of the big advantages are these are existing contracts or existing vendors, so you're not creating a new vendor relationship. It might be very familiar to your organization if it's used somewhere else. Probably this is going to be lower cost because you might be able to get in on an existing license, and it's already supported within your organization. So these are all really great reasons to do it. What about implementing third-party software built elsewhere? So this is letting someone else do the heavy lifting on software development. If this is a sort of a common maxim. If you have a functional gap, chances are that others do as well. We all like to think that we're unique snowflakes in our laboratories or in our organizations, but the fact is that common problems are common. And so if this is a glaring problem with your LIS, chances are somebody else can help you out, or at least point you in the right direction. And so this might consist of entire modules or applications, or just some useful software libraries. One thing you need to be aware of with borrowing software is licensing, and I think people forget about this a little bit. Software created by individuals usually have a clear license for use, whereas software created by universities or other organizations do not always have clear licensing, and it's not always clear when you have the right to use that or not. I do want to briefly talk about, I'm not going to go into this in too much detail about open source and free software because a lot of this third-party software falls into this category. I will say that the main thing to recognize that there are differences between open source and free software. And there's a lot of confusion about these two concepts and also the implication of the licenses. So I'm not going to spend a lot of time on this, but I just wanted to point out that there's a different definition for open source software versus free software. They're maintained by two different organizations. You can sort of think of it as a little bit of this relationship that all free software is open source software, but not all open source software is free software. And here I mean free as in libre, or as Richard Stallman would say, free as in speech, not as in beer. There is a perception in some organizations that free and open source software licenses are dangerous because they have a viral nature to them, meaning if you incorporate them into software, it will affect other, you'll suddenly have to give away all of your software because they have infected your code bases. But these are all kind of based on this concept of copyleft, which is a play on the word copyright. And this is a general method for making software free and requiring all modified and extended versions of a program to be free as well. So basically it's designed so that if you give software away, a company can't take your software, incorporate it into their product, and then sell it without without benefiting the community, essentially. The GNU General Public License, or the GPL, is the classic example of a copyleft license. And I just want to talk about this briefly. This is designed, again, to promote the concept of free software, and again, requires that modified versions of software that use GPL software inherit the GPL license. And the whole point is that if you copyleft your software, put it under the GPL, that derivatives of that software can't be made essentially closed source or unfree. Importantly, though, for organizations, this does not apply to software used internally. So the good news is that if you're not going to sell or generally distribute the software, it does not, you do not have this kind of inherent need to sort of give away the source code. And so internally used stuff does not need to be sort of shared with the world. I wanted to talk lastly about a fourth option, which is the workaround. So I refer to this as the W word. And workarounds essentially are just living with your functional gaps in the LIS. So I mentioned earlier, is this really a functional gap, and does it rise to the level of needing to be filled? It's true that something can be a functional gap, but not necessarily demand that it needs to be fixed. And so that's why we create workarounds. Now, workarounds are generally disparaged as shortcuts or band-aids or threats to safety, that you're going to kill patients or you're going to make huge mistakes or errors. And I would say that that's true when workarounds are being used to circumvent, a painful but needed workflow. But workarounds can be safe. Perhaps they're just offline methods for filling these functional gaps. So don't be afraid of workarounds is really what I'm trying to say. Sometimes they might be the best option when you've weighed all of your options to just live with the functional gap and to deal with the workaround. So just in summary here, very briefly, functional gaps in the LIS are inevitable. An informal or formal workflow analysis should be conducted to help determine if functional gaps are real or perceived. Buying a solution to fill a functional gap is typically the best option if it is available. And building a solution should be approached with caution and only by organizations with a culture of successful software development. The decision to build a solution should be made for the correct reasons, not for the incorrect reasons, many of which I went over. And organizations that practice software development need to have the right staffing, the right resources, and the right processes in place to support that software development. Borrowing of whole modules or libraries may provide a middle ground between buying and building if you can get this functionality from perhaps an organization that does have a culture of software development. And borrowing requires careful attention to software licenses to make sure you have the right to actually use this software. And workarounds, although disparaged and looked down upon, are sometimes valid alternatives to building out a proper software solution if none is readily available. And that concludes this talk. And I think we have time for questions. Is that right?
Yes, 2 minutes, just in time. Thank you very much. Let me check the chat.
Mario, I have 3 questions. Do you want me to ask the questions to Professor Cornish?
Yes, please go ahead.
Okay, I will write the questions in the chat box too. So if you don't understand my English, you can read them. So the first one is, sorry, I will make it public. The first one is, what is your experience regarding buying a specific add-on created for you by your LIS vendor and then installing new versions of the product? Did you lose the add-on? Do you need to pay again or pay something?
Let me see if so my experience with buying a custom add-on and then what the sort of what the contractual, the costs are.
No, for the new versions, for new versions.
Oh, for new versions.
Yeah.
So I would say that I have a lot of experience with various parts of this. As far as a totally new module, that is probably one of the rarest occurrences. And while I know the stories behind some new modules that were built, I personally have not contracted for a totally new module. That's actually probably one of the few areas that I don't have as much experience in out of all the things that I'm presenting here. You know, in general, my experience though, when I look at some of the modules that have been created in partnership, so you know, we use Cerner Copath Plus at the University of Colorado for anatomic pathology, and one of the modules that we rely very heavily on is the barcoded tracking system. I forget exactly what it's called, but the barcoding tracking system. Now that module was created in partnership with the University, with University of Pittsburgh Medical Center. So that's UPMC, a very famous place for informatics. So I believe Anil Parwani and Laurent Pantanowitz, when they were there, worked very closely with Cerner to create this module from scratch to fill a functional need, right? Because they wanted to track the assets, the slides and the blocks and things. So that was created by them. And in that case, that became a product, that became an official module that could be purchased by others. And my understanding, and again, you could ask them directly, but my understanding was that once that became an actual module that anyone could buy, that it simply, they may have gotten a special deal, but when everyone else buys that, they of course have to pay a normal price for it and have to pay maintenance. I would recommend personally, if you are paying for the development of a new module and it has commercialization possibilities, that you try to get probably the minimal amount of minimal amount of additional future costs built into the contract. Now, whether you can do that or not, I'm not sure, but nothing is more galling than I think basically sharing intellectual property with a company and then having that company profit on it, and you continue to have to pay them dividends in the future for something that you contributed to. But like I said, unfortunately, that's not an area that I have a huge amount of personal expertise with.
Okay, we have 2 more questions, but
sure,
I think we have run out of time. So
okay.
we will ask you questions through an email to you, and you will be able to answer them in written. So we will include this in the recorded version of this conference. Thank you very much, Professor.
Thank you.
Thank you.